I should first clarify what I mean by implementing continuous delivery. I want to talk about organizational issues, process issues, and architectural issues. I'm not going to be spending any time talking about tools or code or infrastructure or any of the technical details of implementation. This is mainly about organizational process issues of implementing continuous delivery. So if you're expecting a highly technical talk, then this is not it, and I will not be at all offended if you drop off at this point. This talk is aimed at everyone from developers to operations people to managers, but it's focused on the process side of actually do you get an organization to adopt continuous delivery. So with that cleared up, hopefully everyone has some idea what I mean by implementing that. I'm going to present the top 5 things that I expect you to take away at the end of this. These are the main things that I want to impress on everyone listening. First of all, you need to understand why it is you want to change. There has to be a reason why you want to achieve continuous delivery, and that reason should be a compelling business reason that makes sense to everyone in your organization, whether it's management or practitioners, whoever it is. There has to be a reason to do it. And that reason has to involve some measurable quantity changing, whether it's a decrease in the number of failed releases, an increase in the quality of the software going out, being able to react more quickly to users, not spending weekends in data centers doing releases anymore, being able to do more releases. All of these are valid reasons for implementing continuous delivery, but you need to have a reason, obviously, and everyone has to be on the same page as to why you want to do it, and those changes that you expect to implement should be measurable. Moving a whole organization towards continuous delivery can take a long time, and typically from a medium or large organization with existing process and systems in place, it's going to take between 1 and 5 years, and that can be quite scary and worrying. And so the important thing is, like with a project, don't wait 1 to 5 years before delivering something. You want to make sure that even if the initiative is going to take a long time to achieve your goals, you want to show measurable change fast. You want to be able to demonstrate, here's some change that here's some low-hanging fruit, here's some problems we can solve in the first few weeks, or at most a month or 2, that demonstrates that we're actually making a difference to people's lives, and that's really important. A lot of time when people implementing Agile, they start with things like stand-ups and planning and a lot of the project management activities. With continuous delivery, we believe there's a fundamentally different approach that you need to take, which is to start with the technical practices, such as continuous integration. And continuous integration done right is a really big game changer, and it's not nearly as widespread as it needs to be. There was a recent survey that said something like 46% of enterprises are using continuous integration, and most of them are not really doing continuous integration. They're running a CI server against their feature branches, which is not continuous integration. In implementing continuous integration, you run across a number of problems. And the root cause of most of those problems is around the organizational structure and the architecture of the systems being built. And you need to be prepared to work on those issues, on organizational structure and architecture. Those issues need to be addressed, and everybody needs to be aware that you're going to have to do that. The magic CD fairy, which I'm going to refer to a lot, is not going to magically make your architecture able to be continuously delivered. And then finally, the most important thing you can do when you're implementing continuous delivery across an organization is to create a culture of continuous improvement where everybody wants to learn and to improve what they're doing, and you're constantly thinking of ways that you can make things better. And that's all there really is to Agile. That's the most important thing in Agile, creating that culture. And if you do that, you don't really need anything else I'm going to tell you, because you can work it out for yourself. So, with that said, I just want to briefly discuss what is continuous delivery and what are the benefits. And I'm not going to spend much time on this because this is the 12th webinar in the series, and hopefully you have a good idea of that by this stage. So this is a brief, informal definition. The point is that you want to reduce the cost, time and risk of delivering incremental changes to users. You want to make it cheap and low risk to put out a new change to users. And that's true whether you're working on web software, on embedded systems, on products, or whatever you're working on. You want to make it cheap to push out new changes to users. Why do you want to do that? Well, there's three reasons. Firstly, building the right thing. I often quote from the Standish report, or a Standish report that was delivered at XP 2002 that says that based on some surveys they did on Department of Defense code bases, more than 50% of features that people built were rarely used or never used. And that's the biggest source of waste in the software development industry, stuff that we build that's never used or rarely used. And whenever we decide we're going to build a product based on software, what we do is we come up with a hypothesis. Here's a business idea. We think this will be valuable. And then the most expensive thing you can do to test that hypothesis is to actually build it. So we shouldn't do that. What we need to do instead is create this really tight loop where we can come up with ideas, produce the smallest possible amount of work to validate whether the idea is valuable, get feedback from real users on that idea, and then cycle. There's this guy called Eric Ries who wrote a book called The Lean Startup that came out last year. If you haven't heard of him or haven't read the book, then you should. It's an excellent book. And he talks about the concept of a minimum viable product, building the smallest possible amount of stuff to test your business idea and getting fast feedback. And when you're doing this, what you're doing is reducing the risk that you're going to be building the wrong thing. And in order to do that, what you need to do is focus your software delivery process on reducing cycle time. The time from having an idea to getting feedback from the market. Aim to make that cycle as short as possible. Cycle time reducing cycle time is one of the main goals of continuous delivery, and reducing the transaction cost of putting out releases so that you can do it as frequently as possible. The second reason to do continuous delivery is it counterintuitively reduces the risk of release. If you're releasing every 3 months, the amount of stuff you're releasing, the delta, is large. And so what that means is there's a lot of things that could possibly go wrong. And of course, when there's a lot of things that could go wrong, usually some of those things do go wrong. How do we reduce the risk of release? Well, actually what you want to do is release more frequently. Because then what happens is the amount of stuff that's changed is much smaller, and that means it's much easier to find out what the cause of any problem is. If you're releasing multiple times a day, then the delta is sufficiently small that you can say, well, the release failed, why? Oh, it was these 3 lines of code, or this Apache configuration setting, or this database migration. And then it's much easier to remediate those changes as well, because there's much less stuff to remediate. And furthermore, finally, you're getting a lot of practice in deployment, and clearly practice makes perfect. And thus, releasing more frequently is a great way to reduce the risk of release. This has been demonstrated many times with real data. Famously, when Yahoo acquired Flickr, Yahoo were doing traditional release processes. Flickr were releasing many times a day, and Flickr, in the year they looked at the uptime stats, had higher uptime than any of Yahoo's major services. So there is data that backs this up. This idea that high throughput and production stability are mutually exclusive is not true. If you do it right, with a lot of discipline and care, then those two things are complementary. Finally, continuous delivery gives you real project progress. If anyone installs Windows 95, you will remember that progress bar that occurs when you're installing, and it chances along installing Windows, and you get to about 80%, and then it stops, and you go and make a cup of tea and come back, and it's still at 80%, and you think, well, okay, do I make another cup of tea at this point, or do I reboot the computer? For the project managers listening, I'm guessing this is pretty much how project management feels to many people. You get 80% done with your features, and then you discover, the system won't actually scale to the expected load, or we can test for security, there's some security problems. The architecture we put in place doesn't fundamentally support the performance characteristics we're expecting. These kinds of problems are very, very common, and most of the risk in delivering software occurs after they're complete and before go live, or during go live if you're really unlucky. So what we want to do to change that is change our definition of done. Dev complete is not the same thing as done. Dev complete means it works on a developer workstation, but when the developer says, I'm done, it works on my machine, do you believe the developer? Hopefully not. The only real definition of done is having software, having your features live in production, delivering value. And when you do that, and you release more frequently, what that allows you to do is actually have a meaningful definition of how far you are along with your product or your service or your project. On this chart, on this slide, you can see a burn-up chart. The grey line at the top is scope. The red line is work in dev. The orange line is work that's tested, QA passed, and the green line should be live in production. Burn-up charts, as an aside, are really useful. You can see from this chart the horizontal distance between the red line and the green line is the cycle time, the time from check-in to release, and the vertical distance between the red line and the green line is batch size, the amount of stuff you're working on at any one time. I said earlier, continuous delivery focuses on reducing cycle time. It should be intuitive to everyone that the easiest way to reduce cycle time is to reduce batch size. Reduce the amount of stuff that your team is working on at any one time. That will allow you to get stuff out much more quickly. And it's really hard for people to do that, and especially for management to get over the kind of brain freeze you get around reducing batch size. Do less stuff, and then you can deliver it more quickly. It's easy to say, it's really hard to do. So, when you're doing continuous delivery, your software is always releasable on demand. At any time, you can press a button and release the latest good version of your software to production, and you know what the latest good version is, and that you feel comfortable releasing it. Continuous deployment is pressing that button all the time, releasing the latest good version to production all the time. Continuous deployment means it's releasable. You may not release it multiple times a day. You may release it once every 2 weeks or less frequently if it's a user-installed product, but it's always releasable, and you prioritize keeping the system releasable over delivering features and fixing bugs and velocity in general. It's more important to make sure the system is working and that your delivery system, your build and deployment process and automated tests are working. That's more important than delivering bugs and features. And then crucially, it gives you visibility into the delivery process and feedback. Everybody should be able to get fast, automated feedback on the effects of a change. If I check into version control, I should be able to get some feedback in a few minutes on if I've done anything really stupid, and more comprehensive feedback at most an hour or so on if I've introduced regressions into the system that are going to cause problems. So I should have put this page up, that would have explained it much better. If you check into version control, that should trigger a build of the latest version of the software with your changes, and the unit test should run. And in this first check-in, the build breaks, and at that point, people should stop what they're doing, and someone should volunteer to fix the problem, and no one should be able to check into version control unless they're checking in a fix to that problem. And that's something you should get that feedback in a few minutes. If you're working on a really old, gnarly C++ code base, things may be, it's going to take longer, understandably, maybe an hour or so, but most of us aren't in that situation, and you should be able to get feedback in a few minutes. Similarly, the next check-in should be the check-in that fixes that problem, and if it takes more than a few minutes for that problem to be fixed, the check-in that caused the breakage should be reverted from version control. The next check-in should fix that problem, and then the build should run, and the test should run, and you get a green build. And then that green build will trigger a run of the automated acceptance tests, which are a more comprehensive but longer running set of tests that validate if there are any regressions and if the software is really working. If that breaks, as it does in this example, the team again stops what they're doing. Someone volunteers to fix the problem. Everyone can carry on working, but the highest priority of the team is fixing those automated acceptance tests. When you have a build that passes the acceptance tests, then the people downstream get notification, here's a build that's passed all the automated tests, and you can then go and do manual testing, usability testing, exploratory testing, showcasing. There is a place for manual testing in the process of delivering software, absolutely. Humans are really important for doing things like usability testing and exploratory testing. They're terrible at doing manual regression testing, and so all that stuff should be automated. But the later stages of the pipeline involve manual tests, manual validations, And those are further down the pipeline because you don't want to waste your time doing that on a build that hasn't been shown to be good as far as the automated test proof. And then once the build has passed all the validations, you should be able to press a button and release that build or any other builds to staging environments and then to users. So you get visibility into the status of your system, into its production readiness, feedback on the effects of any changes, and control the ability to deploy any version any version of the software to any environment you have access to. So that's this idea of a deployment pipeline, which is the key pattern in continuous delivery. And as I said earlier, we're focusing on reducing cycle time, so you want to make that deployment pipeline as short as possible and make it as wide as possible through parallelization, running automated tests in parallel, running manual validations in parallel where possible. So, having covered the deployment pipeline, I want to talk about some projects we've worked on. I spent as much time as I really want to on the theory. I want to talk about some projects that we worked on here at ThoughtWorks. We can't name those projects, unfortunately. It's very rare that customers will give us the permission to name the projects that we're working on. But the flip side of that is because we're not naming them, I can talk about them very candidly. The first project I'm going to present is one that was extremely successful, both for the practitioners and for the business. And then I'm going to present some less successful projects later on and look at those. So I want to talk about a project that we completed recently in the UK. There was about a team of 20 people roughly working on that. It was a web-based project, and right from the beginning, the practitioners had complete control over their process. They were able to do more or less whatever they wanted in terms of their methodology and the choice of delivery. The business had requirements and they had a deadline when they wanted to go live, but they said to the team, you can actually deliver this in any way you want. And so what they decided to do is start with continuous delivery. And what that meant is they actually planned up front for delivering multiple times a day, or the possibility to do that. And that affected the architecture they chose. So they chose a Ruby on Rails architecture for the front end because it's just much easier to do zero downtime. For example, when you're doing a new deployment, authentication happens by the database, so there's no session data, so you don't have to worry about migrating session data when there's downtime. They put HA proxy and Nginx in place. They started from the beginning to consider how it would be possible to create production-like environments for the developers, so the developers can be testing right from the beginning on production-like environments, even on their machines using virtualization. They created stories right from the beginning for setting up the deployment pipeline, setting up the environments as part of the inception of the project. It wasn't just talking about requirements, they talked about how are we going to build our automated tests, how are we going to build our deployment pipeline, and they came up with real stories for those. And they actually worked out it was going to be a fair amount of work. They ended up dedicating one of their 4 development pairs to working on the deployment pipeline and automating the environment provisioning, and that made a huge difference to their ability to actually deliver functionality that would be known to work in a production-like environment. That seems like it should be a hard sell, spending a quarter of your capacity working on this kind of work rather than on features. But what it meant is the project was able to launch early because we were able to have conversations, we were able to find the risks in the technical delivery early on, we were able to find risks in the requirements early on, we were able to have discussions with the stakeholders early on, and so what that meant is that all the risky stuff was done a lot earlier on in the project, and so towards the end it became very, very predictable, and we had the system ready, or the team had the system ready. I wasn't involved in this, I should say. The team had the system ready a week before the actual release of the system, and that was just marketing, basically. We're going to turn it on now, but the system was ready to receive transactions much earlier than that. The team's able to do multiple releases a day, and actually what's happened is the business has said, we don't want release releases multiple times a day. We have other dependencies on other things such as marketing and support, and we want to release once a week. And that's a huge deal because it means that IT is no longer the constraint. Business is the constraint. IT is waiting for the business to say what they want, and then they deliver it really, really quickly. So that is a really magical thing when the business is no longer waiting for IT to deliver things. IT is waiting for the business instead. So that's a huge payoff. It means releases are really boring, and it means the maintenance of the system is really, really cheap because deployments are push button to testing and production environments. There's automated testing, and so it will be easy to scale down the team and keep pushing out releases, and it's much cheaper to maintain systems that are built in this way. So there are still some problems with this project. One is that we need someone who's full-time working on the deployment pipeline. And it turned out there was one person on the team who had the skills to understand how to automatically provision environments with Chef, how to build deployment pipelines, how to do continuous integration properly. And he became the bottleneck on the project in some ways. And so skills are a big problem in continuous delivery too. Hopefully many of you have heard of the term DevOps. So DevOps, I guess one of the earliest presentations on DevOps was this presentation by John Osborne and Paul Hammond at Velocity in 2009. It was called 10 deploys per day, DevOps cooperation at Flickr. And they kind of had this nice slide on DevOps. Developers are a little bit weird, they sit close to the boss and think too hard, and operations tend to pull levers and turn knobs, are very easily excited and yell a lot in emergencies. And so there's this conflict between the way that developers think and the way that operations think. Developers are measured on throughput, operations are measured on stability. There's a conflict there, and we see that all the time. The developers are constantly cursing the operations people for stopping them putting out their code. The operations people are always cursing the developers for creating horrible, crappy code that doesn't actually work in production. So there's a culture clash here. And DevOps really is about saying, well, the way to solve this problem is for people to collaborate from really early on and to share skills and to share knowledge and experience and to work together on automation of build, deploy, test, and all these activities that are necessary for continuous delivery. The problem is, it's really hard to find people with both of these sets of skills. There's a big skills gap, and in fact, there's a blog post here called How to Hire DevOps. And so lots of organizations are saying, well, we need these skills, we're going to hire a DevOps. And I mean, it's worth reading this. DevOps is the latest big trend in hiring. Everyone's talking about it, everyone wants them. How do you find them? How do you hire them? What should you look for? And then this paragraph is really revealing. The dirty secret, here's the confusing part. There's no such thing as a DevOps. You'll have a hard time finding someone whose business card says DevOps. You're actually looking for a developer with some experience and knowledge as a sysadmin, or a sysadmin with some experience and knowledge as a programmer. And those people are really hard to find. And the problem is, I mean, we know it all works. It's one thing to hire computer science graduates. It's another thing to hire people who understand how to build systems that are maintainable, that work well in production environments, that are deployable, that are testable. But those are not things that we often teach in computer science. And the skills that are required in operations, I mean, operations isn't a skill. Operations is a massive cluster of skills around network management, around database administration, around storage management, around root cause analysis and how to react in emergencies, how to build resilient systems, and none of this stuff is trained for. There's no body of knowledge that's broadly accepted on how to acquire these skills. It's mainly done by working in environments that are high stress for a long time and developing a strong intuition. And so it's really hard to hire these people, and this is one of our biggest constraints. So the main thing I want to say about DevOps is most companies say, well, we want to move towards continuous delivery, we're going to hire some DevOps. And we're going to put those DevOps in a separate function, and they're going to bridge the gap between our existing dev and our existing ops functions. And at that point, you have failed. You've missed the whole point of DevOps. That talk that Osborne and Hammond gave at Velocity 2009 was called 10 deploys a day, Dev and Ops cooperation at Flickr. It's not about hiring a DevOps so that you don't have to do the cooperation. It's about enabling the cooperation so that dev and ops can share those skills and work together and develop that knowledge about how to create deployable code and how to maintain systems in production that are highly stable in the face of change. So that, we have to be really careful of this, because this is the way DevOps is going. People are thinking they can just hire DevOps and the DevOps people will fix their problem. They don't have to change anything about the way they work, and that is absolutely not true. And if you try and do that, what you'll find is you can't hire these people because there aren't enough of them. And there will never be enough of them as long as you do this, because when you hire a DevOps and sit them on their own in a room to fix your problems, they will never transfer their skills, and we will never find a way to create more of these people. I mean, the very first time I worked I kind of achieved continuous delivery with a team of people much smarter than me in 2005 who taught me a lot of what I know. We had a release team. It was a DevOps team of 8 people that was supposed to bridge the gap between Dev and Ops, and we were reasonably successful in that. But it was a band-aid to fix an underlying problem, which is that Dev and Ops were not talking to each other. And that's the problem that DevOps is supposed to fix. So, having ranted a bit about DevOps, I now want to talk about the path to continuous delivery. So, how do we actually get on this path? So, it kind of sounds a bit pretentious talking about the path to continuous delivery, but the point I'm trying to make is that it's not a destination. It's not a project that you can start and then there's an end date, and when you achieve the end date, you're done. It's something that you're always doing. The best way to achieve continuous delivery is through continuous improvement, through looking at what's problematic, look at what the constraints are in your system and try and remove those constraints and reduce the transaction cost of putting out a change and reduce the risk of putting out a change. It's a path because it's probably going to take a long time. If you have complete control over your systems and you're not beholden to some other group who is not going to practice continuous delivery but whose software you must integrate against, if you have complete control over your stack and your people and leadership buy-in and practitioner buy-in, you can probably achieve continuous delivery in the sense of releasable software on demand in about a year. If you don't have that, if you have multiple groups and you don't have buy-in from all the groups and you don't have leadership support, it's going to take you more like 5 years if you manage it at all. And this is the crucial thing, the most important thing that people need to take away from this talk. It's going to be hard. It will be hard. No one is going to wave the magic continuous delivery wand and give you releasable software on demand. The key, even though it's going to take a long time, is to regularly demonstrate measurable change. Hence this nice picture of an oasis that I took on the trip in Iran. You need to make sure there's lots of oases along your journey, that there's times when you can say, here's something you've done and it's really great, and you can infuse people and make them feel, actually what we're doing is really worthwhile and it's making life better for people. If we're not making life better for people, then what's the point? And we have to our continuous delivery initiative, the biggest requirement of that is being able to demonstrate measurable change frequently, just as you try to do with your software. So, I'm going to discuss a case study from an organisation that moved to continuous delivery in 3 years. And this is not a ThoughtWorks customer, and hence I can name it. And actually there's a book coming out later this year by the people who achieved this change. It's called A Practical Approach to Large-Scale Agile Development by 3 guys, Ruger, Young and Fulgham. It's coming out, I think, November this year. This was the HP LaserJet firmware team. The people who built the firmware for LaserJet. And they had a problem. Their problem was that if you look at where they were in 2008, they went round and they recorded how much time people on their teams were spending on the various activities required to build the firmware for new printers that HP were making. And the results are pretty terrifying. You can see they were spending, let me just roll back a bit. They had a different branch for every product. For every HP LaserJet printer, there was a separate branch of the code for the firmware. And so they were spending 25% of their time porting code between branches and porting bugs and features between branches and making sure the software still works at the end. Product support was really hard for current products because you had to work out the right version of firmware to build and then try and instantiate that and try and debug it. It was really painful. They were spending a lot of of time on manual testing. There was a bunch of different teams. There was over 100 people involved in this project, distributed between multiple sites in the US and India, and they all had their own backlogs of work, so they were spending a lot of time on detailed planning. Code integration was very painful, and what they discovered is they were only able to spend 5% of their time on innovation. Now that's terrifying, and it was utterly unsupportable, and so the business came to the IT people and said, we need to fix this. This is unsustainable. And so they did. And in 3 years, they moved to a model where they were practicing continuous integration. Everyone was checking into Trunk. They had automated tests in virtual environments and also in simulated logic board environments that validated that the changes to the firmware would actually work on real logic boards, fully automated. They had most of their testing automated, and what they were able to do is move to having 40% of their capacity dedicated to innovation, which is a huge change. And bear in mind, this is taking 3 years, and they had complete executive support. And that should make people pause. Now, initially it was difficult to make. This is embedded software. This is firmware embedded in hardware. It's a hardware product. The lead time on some of the parts in this hardware over a year or so. So, that's part of the reason why it took so long, plus the distribution and the large size of the team. But they did manage to achieve this huge change. And these were the changes. They reduced development costs by 40%. They increased the number of programs under development by 140%. Development costs per program were down 78%, and resources driving innovation increased by more than 5%. So, if you want an economic justification for continuous delivery, it does not get much better than this. This is really powerful as an economic justification, I think. No one can really argue with that. And the HP LaserJet firmware team did it, and they wrote a book which I urge people to read when it comes out. There's a rough cut on Safari, and they did it in embedded software. So I really think there's kind of no excuse for people to say that continuous delivery is going to be impossible if these people can do it. They did a sterling job, and they did it before continuous delivery was invented. I mean, the book that me and Dave wrote came out in 2010. These people were doing it in 2008. They did it through continuous improvement, just by considering what the problems were and trying to solve their problems one by one. That was how they implemented it. They didn't read anything, they didn't get any experts, they just sat together and worked out how they could fix the problem. What did they change? They changed the architecture. They rebuilt the system from scratch in such a way that they could have a single code base that would work on every printer, but they could control which features were turned on and off, depending on the printer that was being used. And actually, the firmware queries the printer when the printer is switched on to find out the model of the printer and switches on and off the various features dynamically. So that was the main requirement of the architecture they built, that it should work on all the printers. And that's what enabled them to make sure that everyone was checking in on mainline. And they implemented continuous integration, which meant that everyone checked in on mainline, and when you check in on mainline, automated tests run to validate whether your change actually works, and they implemented auto-revert. If your change is checked into mainline and the tests fail, your checking gets reverted automatically. It was a large C++ code base, so it took them an hour or so to get that feedback, but if they get that feedback, your change gets reverted automatically. The other things they did is to change their planning process, their project management process. And what they did is they created a unified backlog for the whole team. And they prioritized that backlog by importance, and so you had, for every month, they had a milestone, and they prioritized the features that were going to be delivered in that milestone, and the whole team worked on implementing the various bits and pieces that had to be done for that feature to be delivered. So those are the main things that changed. I can't spend any more time on this, but I do urge you to go and read that book if you're interested in how they did this. Changing architecture is hard, and it's very easy when you're building a new architecture to spend several months thinking about it. And one of the big things they did in HP is they made sure they were demonstrating working software with the new architecture right from the beginning. From the very first month, they were demonstrating and showcasing working features using the new architecture. And that was really important to their ability to progress rapidly. And it kind of validates what I'm saying. We have this kind of term, which I don't really like, called organizational transformation. And the key thing in organizational transformation is you should be aiming to achieve measurable change as soon as possible and no more than a few months. The other key question that people consider is, should change be top-down or bottom-up? And the answer is, it should be both. You need to have executive support in order to move to continuous delivery, because it's going to reduce your velocity. You're going to have to spend time maybe rebuilding your architecture, which is going to be expensive, certainly building continuous delivery and automated testing, which is going to slow your developers down. And when their check-ins get reverted, it's going to slow them down. And when they have to fix bugs and focus on keeping the system working and developing features, that's going to slow them down. It's going to upset people. So you need the executive support. So I want to address one question. Someone here said, the case study about the HP project is interesting because my assumption on firmware is that it's not frequently released. Well, let me just clarify this. Continuous delivery means that the software is always releasable, not that it's always released. HP are confident that they can release that firmware at any time, the latest version at any time, but they don't release it all the time. However, they do have quite frequent releases of the firmware, and that firmware is downloadable onto the printer. So there's firmware updates quite frequently, and they've been able to increase the frequency of their firmware updates as a result of moving to continuous delivery. So people assume that embedded you have these long cycle times and infrequent releases. That's not actually the case, and a lot of organizations are moving to a model where the firmware and the software is updatable much more frequently than the underlying hardware. And being able to do that is actually a huge competitive advantage. So, back to this. You need executive support in order to be able to make this change, but you also need the practitioners to change the way they're behaving and to be happy about that change. You need practitioners to actually focus on continuous delivery and make sure that they're keeping the software releasable at all times, and that they are actually paying attention to the CI build, so when it breaks, they fix it, and that they are paying attention to the automated tests. So the automated tests actually, when they're green, it means the software is releasable, and when they're red, it means there's a real problem, not that the tests are flaky. So everyone needs to work together to achieve continuous delivery. As I talked about self-organisation is not enough. I've seen self-organised teams be totally chaotic and completely unable to actually deliver real code. I mean, there's a quote from Apple from the days of the Macintosh where they say, real artists ship. That's really important. Discipline is really important. So you need to get the practitioners on board and help show them how continuous delivery is actually going to improve life for them. So, as I said earlier, it's important to start with continuous integration. You need to make sure that you know that the system is working in the face of any change to it, whether that's code, infrastructure, database schema, configuration. Any of those changes should trigger a build, and you should get rapid feedback on whether you broke something. And crucially, if you broke it, you fix it. That's one of the key points of continuous integration. It aligns the pain of the system being broken with the person who has the power to fix it. Without continuous integration, something goes wrong in production, you don't know whose fault that is. And it's not about assigning blame. It's about finding the people who know how to fix the problem. With continuous integration, if your change breaks the system, you find out pretty soon, within minutes or hours maximum, if you introduce a problem and your change gets reverted. And it's your problem to make the system work. You're aligning the pain with the person who has the capability to fix the problem. And that's why continuous integration is so important. It enforces a minimal level of done. You can't say you're done until your change has made it into mainline and past CI. And CI enforces that. And what the deployment pipeline is about getting progressively more rigorous in your definition of done, effectively. So, you need to do continuous integration. You need to put it in place. You need to make sure the build is consistently green and that the team prioritizes keeping the build green. That's the most important thing, first step that you can implement. Continuous integration means that, I make a change. When I make a change, I run the unit tests and the build locally. If they pass, I merge in from trunk, and then I run the tests and the build and the test again to make sure my changes work with the changes that other people have made. If that passes, then I check into mainline, and then I have a CI server that makes sure that those that version of code works on a more production-like environment, and then I can say I'm done. And crucially, if you're doing continuous integration, that means everyone is checking into trunk at least once a day. Otherwise, we're not doing continuous integration. Running Jenkins against your feature branches once a day is not continuous integration. You need to have everyone checking into mainline at least once a day, and every change should result in the build and the tests being run, and if the tests fail, then the highest priority of the team is fixing the tests and making sure the system is releasable. Most people who say they're doing continuous integration are not doing continuous integration. And the key is in the word integration. If you're working on feature branches, by definition, you are not integrating. So, if I sound a bit frustrated, it's because every talk I give, I ask this question, and you find that most people who say they're doing continuous integration are actually not. Now, it's one thing for teams to be doing continuous integration. You also need to be doing continuous integration at the system level. So you probably, if you have a system of any complexity, have a bunch of different modules, and you need to make sure that those modules are working together properly. If I have a system like the one shown, and there's a change to the shopping cart component, I need to rebuild the system with a new version of the shopping cart and the latest good versions of the product catalog and recommendation engine in the platform, and run some system tests against the whole system, automated acceptance tests to prove that the whole system works. And if it breaks, then it's the shopping cart team's job to fix that problem. You don't want to be doing integration of your components or your services at the end of your program. You want to be doing it all the time, and if CI at the system level breaks, it's the problem of the team who are building the component that broke it to fix it. Again, you're aligning the pain, the responsibility with fixing that pain, to the people who can fix it. Excuse me a second. Right. There is one thorn in the side of a lot of people, which is that they don't have control over their entire system, and often you have to integrate with things like payment services or CRM systems that do not follow continuous integration. And this is usually what makes it a 5-year problem, not a 1-year problem. Or if some of the parts of your system are not under your control, say the product catalog team is run by a separate division, and they can't. They're not interested in continuous integration or continuous delivery. That's normally what makes this really painful. So there are some solutions to this. Often the underlying cause of the inability to move to continuous integration is feature branching. People can't move away from feature branching because they have a monolithic architecture. And in fact, there's this great quote from a colleague of mine, ex-colleague of mine, I guess, Dan Bodar. He says, feature branching is a poor man's modular architecture. Usually when people can't move away from feature branching, it's because they have a big monolithic architecture and it's just too painful. And this is the reason why HP rebuilt their new architecture, because they wanted to build an architecture that was modular so they could do trunk-based development. And, this is important. HP realized that to deliver their business goals, they had to do continuous integration. In order to do continuous integration, they had to have an architecture that supported checking in on trunk, so they rebuilt their architecture. That is a totally valid thing to do. And it was not a small system. HP's firmware is incredibly complex. It has its own operating system. This was not a small undertaking. But the business requirements led irrevocably to the conclusion that they would need to rebuild their architecture, and so they did it. In order to be able to develop on trunk with large teams, you need a service-oriented architecture or a componentized architecture, basically not a big monolithic architecture. And there's a link here that I've got, bit.ly/this first link. That's a link to Steve Diego's platform rank, where he talks about how Amazon has in fact created a platform like this, as opposed to Google, which hasn't created a platform like this. This is really worth reading in terms of doing this. Amazon, like HP, decided to move to a componentized architecture so they could release more frequently. And They made it their biggest business priority to rebuild their architectures to support componentization. And they hired a Marine to go around all the teams and make sure that they were talking to each other through their interfaces, not to each other's databases. There's techniques like branch by abstraction that let you make large-scale changes while working on trunk. There's a pattern called the Strangler application, which is about replacing monolithic apps piece by piece, so you don't have to do a big bang replacement of your monolithic app, which is obviously the worst possible thing that you can do. So, here's some approaches to help you deal with feature branches. Testability and deployability is actually a constraint on your architecture. You need to make your architecture or design your architecture in such a way that it's easy to build and deploy your system. Your architecture should support developers standing up the system, maybe in virtual machines, on their dev environment. Your architecture should support the ability to run acceptance testing against your service or component in a non-integrated environment and find 80% of the bugs. You should be able to create test doubles for external services you depend on for running these acceptance tests, so you can perform acceptance testing in a non-integrated environment. You need to design your system so that you can stand up new environments on demand based on information in version control, rather than having environments that are works of art that need to be manually created and managed. These are some of the key points in architecting for testability and deployability, and this is really important. You must do this if you're going to move to continuous delivery. So I'm going to talk about another large organisation that I'm unable to name that we did some work for. Very large organisation, distributed, and they wanted to move to continuous delivery. In a year, they were able to move from 1 release to 2 releases a month, and they achieved a 40% reduction in their cycle time. And they did this by focusing on low-hanging fruit. They had a bunch of branches. They reduced the branches. They didn't eliminate them, but they got rid of the most volatile branches and making sure that the people doing the most changes were checking into mainline, and they still had some branches. They made it possible to run tests on development environments. They were able to perform some standardization in the environments and decrease the build time. They were not able to achieve continuous delivery, but they did achieve some measurable results in a year. And speaking to the people on that project, one of the things that came back was that they wished they'd focused on achieving measurable change sooner and in smaller increments. They also achieved some level of program coordination. The biggest barrier for this team was that there was 2 parts of the organisation. There was an organisation that ran the website, and there was an organisation that ran the back-end booking systems. And those 2 parts of the organisation, only met at the C-suite. And so the booking system people were not doing continuous delivery. The website people were doing continuous delivery, but they depended on the back-end people to implement any of the big features they wanted to implement. And so they weren't able to work together to achieve continuous delivery, but what they did do is they managed to do program-level coordination between the booking system people and the website people in order to improve the level of coordination so they could plan features and release them much more smoothly. So, this is an example of the big barrier, not having complete control over your stack. It's going to take you more than a year in a medium or large organisation, but there are measurable things that you can do along the way. So, we're running a bit short of time, so I'm going to kind of skip over some. Okay, I'm getting a Y. Yes, people can hear me. Okay, good. So, in terms of finding the right team, you need people who are interested in changing. If your first team is a team that doesn't want to practice continuous delivery, you're dead in the water. So look for a team who's actually interested in adopting some of these practices. That's really important. Number 2, look for existing capability. So some people will have heard of the Nokia test that Baz Bode put in place. Go and Google the Nokia test if you're interested, and Baz Bode, B-O-D-D-E. He invented that test as a way of informally finding which teams would actually be suitable for coaching around moving to Scrum. So look at existing capability, and we have a maturity model which you can get by going to ThoughtWorks Studio's website. There's a white paper you can download around release management, and you can look at the maturity of teams along all these different axes, continuous integration, testing, environments and deployments, and look for teams that have some level of maturity. so that you're not, you're not starting from scratch. And then the lessons you learn from that team can be used to help other teams that are less mature move to continuous delivery. You need slack time so that people aren't working full time on fixing bugs and implementing features, and you want to be able to demonstrate measurable change. The last story I want to tell is from an organisation which totally failed to adopt continuous delivery, and I certainly can't name this one, but we did a 6-month gig. They wanted continuous delivery. They were completely unable to achieve anything in that 6 months. Why was that? They wanted us to come in and wave the magic CD fairy and make things better. We identified quite early on they had a monolithic architecture, it was an enormous product, and they were doing a water scramble process where there was lots of gates, and when they had problems they introduced more gates to try and manage that risk. And they were unwilling to change that. And indeed, at the beginning, they were unwilling to realise that was even a problem. And so, given that, there was nothing we could do. We still stayed and tried to do things. What we did was we helped them improve their test automation. We helped them think about moving to a continuous integration model. But the architecture didn't fundamentally consider test and deployment. It was hard to run automated. I mean, you couldn't run automated tests. Testing was manual. It took several hours, and when it broke, no one wanted to take responsibility for fixing the tests. And the reason for that was that the business as usual teams, they were not rewarded for fixing the test. It was not considered part of their job. So they would run the test, they would break, no one would care. So there was all these problems around organizational structure, around architecture, and the fundamental problem is they just weren't talking to each other. The organisation was not set up in a way that people collaborated, and it was not set up in a way that actually people were rewarded for trying to fix these problems. So, it's possible to fail at this, and it's very easy to fail at this. And this is an example of where the leadership wanted the continuous delivery magic fairy, but they didn't want to accept the changes they would have to make to their process and their architecture in order to do it. And the practitioners weren't interested in continuous delivery. They were interested in some of it, but they weren't interested in the wider changes because they knew that they weren't in any way going to be rewarded for it, and it was in fact just going to slow them down. So I think the conclusion from this really is that it's all about people. You need to get everyone together at the beginning of any new project or product or service. Operations people, support people, all these people have requirements. It's really important to consider their requirements. Make sure everyone keeps meeting throughout the project. Give visibility into the state of the deployment pipeline, into the state of how people are doing in terms of branches. How many branches have we got at any one time? How often are the tests failing? How long does it take to fix the build? What is our cycle time? What is our lead time? What are these numbers? How often are we able to release? And most importantly, you need to institute a culture of continuous improvement. You need to make sure that people are always considering how they can do things better, and that they're actually talking to each other. If you want to make life easier for ops, guess what? You actually have to talk to them. If you want to make life easier for the DBAs, you actually have to go and talk to them. Have presentations where people present to each other, different groups present to each other over lunch. Have lunch and learns, have blogs, have communication at the grassroots level. That's really important, and management needs to encourage that and give people sufficient time in their schedule to actually put this stuff into place. It's like, imagine a woodcutter who's rewarded for cutting down trees, and they have a target for the number of trees they want to cut down, but they've got a blunt axe. And so you're saying to them, you need to sharpen your axe. And they're saying, but I don't have time to sharpen my axe. I have to cut down all these trees. You need to devote time to actually creating a delivery system that enables frequent low-risk releases and keeping your system releasable on demand. So that's all I have to say. These are the takeaways I presented at the beginning. They are still true. You should take those away. And I'm going to take some questions now. So excuse me while I maximize the Q&A window. I can actually do that. Okay, from the top. Thomas asks, is the full pipeline started each time new version is checked in, or does the later stages only start after a certain delay, e.g. at night? No. Changes should propagate instantaneously through the deployment pipeline. So I'm just going to rapidly try and get to the correct slide so I can show this. When the building the unit test pod, that should trigger running of the automated acceptance tests based on the version of the software that created the working unit test. And you should use the binaries, the packages should be created once at the building unit test stage, and those packages should be reused by the acceptance test stage and by the rest of the pipeline. You need to deploy the same thing to production that you built in your build stage, because that's how you make sure that the thing you tested is the same thing that you're releasing. So those changes should go straight through the pipeline, and they should probably get instantaneously. Because remember, we're focusing on getting fast feedback and comprehensive feedback, and on getting that, on minimizing cycle time. There are tools that will help you do this. The company I work for, Global Studios, makes a tool called Go, which provides the infrastructure for this kind of thing. This is why we built it, to make it simple to do this. The problem with nightly builds, nightly builds are not continuous integration. The problem with nightly builds is they're always broken in the morning. So you never get a good build. That's why you have to do this. Next question from Tony. What are the key differences in the role or engagement tactics of the business stakeholders and users in continuous delivery? Well, this is an area where actually we just need to be doing what Agile said in the beginning, which is have the business involved in the development process. That's as true from continuous deployment, continuous delivery as it is for Agile, and we're still not doing it. There's teams that say they're Agile and they don't have feedback from the business. You can't do anything in that situation. You're stuck with waterfall or water scrumfall or whatever. If you can't get real feedback from the business and from your users, you can't do, you can do all the iterative development you want, but if you're not getting feedback, it's useless. You're driving blind. So in continuous delivery, you need to engage with the business stakeholders and the users in the same way that Agile tells you that you should, which is continuously. So, next question. Dennis asks, why do we need to invest in any minute releasable software if we want to release only once a week? We do not want to over-invest. We want to have a just-in-time lean process. Chris, do you have an answer to this? Yes. The answer is, it's a second-order effect. The benefits that you get from continuous delivery, which is that the system is maintainable, that is high quality, that people are always working on the right things, that people are efficient in their job, that you can actually achieve this. Let's revisit what HP achieved. This change, this is the economic justification. They were spending 5% of their time on innovation versus 40% of their time on innovation. This is a second order effect, and the second order effect comes from focusing on having the software always be releasable. You can get some improvement by releasing, once a week. And actually, that's a good way to move from releasing, once every 6 months. You can say, okay, we're going to move from releasing every 6 months to releasing every 3 months. There will be a benefit to doing that, absolutely, and it's a perfectly valid strategy. But I contend that, if you're doing continuous integration right, you get this stuff for free. If you're not doing continuous integration right, you're not going to be able to release once a week. You're going to, or once a month even. So if you're doing it right, then you get releasable software on demand. If you're not doing it right, you're not going to be able to release once a week at all. So, you're thinking about lean in the wrong way. You're thinking about lean as we want to do as little change as possible. Well, that's not the right way to think about lean. Lean isn't about doing as little change as possible. It's about reducing waste in the activity that you're performing. And this is a common mistake people make. People think that lean is about reducing cost, or that it's about not doing much change. You will. If you fail, you will fail because you don't change enough stuff. HP changed their entire architecture to achieve this. Their definition of lean isn't let's be very careful and conservative about what we change. Their definition of lean is we need to actually fix the problem, and that's going to be expensive. So you need to think about lean about removing waste in your delivery process, not reducing cost or increasing the utilization of your people, because that actually doesn't achieve the goal that you want to achieve. It won't fix any of your problems. I think we're out of time, I'm afraid. There are a bunch of other questions. People who have chatted into the QA window, I will attempt to answer your questions over email. Otherwise, thank you so much for attending the webinar today.